Hey, Chris here again, and we're looking at solving equations. We're going a little bit trickier. We're going to have x minus 2 equals 6. So on my left-hand side, I've got x minus 2. On the right-hand side, I've got 6. Some people may just look at it and know an answer, but we need a process so we can find out in the more challenging questions later on. So I got x minus 2. So how do I deal with this minus 2 on the other side? I've only got one x, so I want to line things up, but I've got this minus 2 here. So we may remember from integers that we can have something called zero pairs. So I could look at saying, okay, you know what, I'm going to add another one here and then another one here. So if I did that, now this negative 1 plus 1 is zeroed out, or zero pair. Negative 1 plus 1 is 0, negative 1 plus 1 is 0. So we don't have to worry about those anymore. And I'm just going to move them down out of the way a little bit. But if I do add 2 to this side, the left-hand side, I also have to add 2 to the right-hand side. So I'm going to take those and add another 2 and put them on the right-hand side. Because whatever I do to one side, I do to the other side. So that 2 I added to the left-hand side dealt with these guys, but I had to add 2 to the right-hand side. Now I'm left with x equals 1, 2, 3, 4, 5, 6, 7, 8. So I'm left with x equals 8. Same on the right-hand side of the algebraic model, the same idea. I've got x minus 2 equals 6. I would like x on its own. So I've got minus 2. To get rid of the minus 2, I'm going to add 2, but I have to do it to both sides to be fair. Now I've got x minus 2 plus 2. Negative 2 plus 2, remember from integers, is equal to 0. And I'm left with x equals 6 plus 2 is 8. So going back to those integers, if you're stuck with the negative 2 plus 2, it becomes 0. But you can also see it here. Negative 2 plus 2 is 0 because each of these are 0 pairs. So we've added 2 to both sides. Okay, we're getting a little trickier now. I've got 3x minus 1 is equal to 8. And again, that minus 1 doesn't have anything on the right-hand side to balance it out with. So what I could do is go back and say, you know what? If I put a positive 1 on this side, then I can zero it out like I did in integers. Now I've got negative 1 plus 1 is 0, and I'm just left with 3x on the left-hand side. But remember, if I add 1 to the left-hand side, I better add 1 to the right-hand side. And so now I've really got 3x on the left-hand side, and I have 9 on the right-hand side. And then I just have to distribute them evenly, or divide them evenly between the 3 x's. So I'm going to go ahead and divide these up and see what I'm left with. And I'm left with 3x is equal to 9, or each x is equal to 3. So I'm just going to circle that. Each x is worth 3, so I'm left with x equals 3, and I like to put a box around it. Similarly, on the algebraic one, I've got 3x minus 1 equals 8. Remember, I'm going to add 1 to both sides. And now I'm left with 3x equals 9. And keep the equal signs lined up, one equal sign per line. I'm going to divide both sides by 3 because I want to divide it equally between the 3 different x's. And when I divide those out, remember, I'm just left with 1x is equal to 9 divided by 3, which is 3. And again, put a box around it. So again, two-step problem, and we're going to add 1 to both sides and then find out what each x is, so we're dividing by 3. Moving on in this series, we're going to look at x's on the right-hand side, and the next one we're going to look at x's on both sides. Same idea, same principles work through it. Okay, so I've got 2x minus 2 on the right-hand side. I really just want x's on its own, and these minus 2 is bothering me, so I can zero them out again. So remember, we take a 1 and we can add 1 here. I'm going to add another 1 here, and now I've got the negative 1 plus 1 is zeroed out, and the negative 1 plus 1 is zeroed out, so we don't have to worry about those. But since I added 2 to the right hand side, I better add 2 to the left hand side to make it fair. Okay, so I've added 2 to both sides, and now I've got the x's, and then I just want to divide these ones evenly between all the x's, and there's 2 of them this time, so I've got 2 groups, and I'm going to see that I've got x is equal to 4. Remember, you could go back and say stick a 4 in here instead of x, and we've got 2 times 4 is 8 minus 2 is 6. We know it works. We know the answer is going to be fine, so it's a nice check. Same thing on the right hand side, so I can again do it the same way. I can just not worry that the x's are on the right hand side. I'm going to add 2 to both sides, and now I've got 8 is equal to 2x, and then I want to divide those evenly in the 2 groups, so I'm going to divide both sides by 2, and I'm left with 2 divided by 2. Remember, it's just 1x. We're too lazy to write the 1. We're just going to like x is equal to 4. Okay? Or we could say x equals 4 doesn't matter. We could have at the beginning rewritten this thing as 2x minus 2 equals 6. If you like that better, that's just fine too. Okay, same thing again. We're looking, now we've got x's on both sides. I'm going to start out the same way as I always have. I'm going to go start out and say, you know, I got this plus 4 here. I wish I just had x's on here, so I'm going to get rid of this 4. So if I take away 4 from the left-hand side, I better take away 4 from the right-hand side. So now I've got 3x equals 2x plus 2. I just want x on its own. So what I could do is, I don't want the x's on the right hand side. I could take this x away and take this x away, but I better do the same on the other side, so I can also take away 2x. And now I'm left with 1x equals 2. Okay, these ones take practice, so I encourage you to do lots of practice on these. Same thing on the right hand side then. I said I wanted to get rid of the 4 first. Let me just change the color of my pen for a minute. I'm going to minus 4 from both sides. And I'm left with now 3x equals 2x plus 2. And I just want x on its own. I don't like the x's on both sides. So what did I do in the visual model? I got rid of the 2x's on the right hand side. So it just had numbers on the right. And so I'm going to do the same thing here. I'm going to minus 2x from both sides. Okay. And then I'm left with 3x minus 2x is just x. Equals 2x minus 2x is gone. I'm just left with 2. Okay, so same idea, same answers. Remember, you can also check this if you want to. You can stick x on each side. 3 times 2 is 6 plus 4 is 10, or on the right hand side 2 times 2 is 4 plus 6 is 10, so they make the same on both sides.